Hey, yo, what's up, guys? Today we'll be talking about minimize Manhattan distance from weekly contest 391. And if you guys were trying to solve this problem with DP, you'll probably end up like,
お前はもう死んでいる。何
and that's how me and probably a lot of people and probably you guys end up as well. And this is completely fine. And that's why we'll be talking about this problem. But we'll try to solve it in ON time complexity. And before we start talking about the problem, let's read the problem first. So you are given an array of points representing integer coordinates of some points on a 2D plane where points I is represented by xi and yi, and the distance between 2 points is defined as their Manhattan distance, and we have to return the minimum possible value of the maximum distance between any 2 points by remove exactly 1 point. So let me talk about what is Manhattan distance first. Since our distance is defined by Manhattan distance, so basically Manhattan distance between 2 points is we have to subtract the x coordinate between the 2 points and we get the absolute value plus we do a subtraction between the two y points again, like one of them minus the other one. But this time we want to get the absolute value again, and we get the absolute value of x and the absolute value of y, and we sum them up together, and that's Manhattan distance. And right now, let's see what do they want us to return. And let me get the some draft note as well. So we want to return the maximum distance, but not exactly the maximum distance. We want to remove exactly 1 point, but those out of those 2 points, we want to return the smaller one. So let's say we got the max Manhattan distance, but right now, let's say we got two coordinates. Sorry for my spelling mistakes. And let's say we say one of them is called P1, the other one is called P2. But we want to remove exactly one of them, and we want to get the smaller one. So let's say we do another max distance again. Repeat. Uh, max. I'm just gonna call this max Manhattan distance. But without P1. And let's say we got this distance called P1 this. And right now we have to repeat again, because this time we have to compare the two, right? Repeat the max Manhattan distance, but this time is without P2. So we call this P2 distance. And we return the smaller one. But hold on, what does it really means in here? Actually, it means we just need to return the third smallest, the third greatest Manhattan distance. Because let's think about it. The greatest Manhattan distance is the one that has both 2 points, right? But right now we exclude one of them, and we are not getting like the bigger one in here. We're getting the smaller one. Because think about it. The bigger one in here is the second one, and the smaller one in here is the third one. So basically, we want to get the third largest Manhattan distance, the maximum Manhattan distance, and that's it. So right now, we have to find the third biggest Manhattan distance pair. And you might say, so what? I mean, don't we just use DP to solve it again? But actually, no. We don't use DP, because why? DP is ON squared time complexity, and we want it to be ON. So right now, let me show you the trick. And this is why like this make this problem hard, because you either know the trick or you don't know the trick. So it's kind of messed up, man. But hey, you know what? It is what it is, and that's why we are going through this together, and just trying to get that software engineer interview, man. So anyway, let me show you the trick right now. So remember, What is the formula for Manhattan distance? The formula for Manhattan distance is, and sorry for my handwriting again and once again, that's why I'm a math major, not an art major, is equal to the absolute value of the x coordinate of one point minus the other point of the x coordinate plus the absolute value of the y coordinate of one of the point minus the other coordinate y point as well. And we just get the sum value and that's it. And right now I'm going to rewrite the Manhattan distance in a different way. The following steps will be repetitive. So I will just do a magic trick and then I'm going to show you the result. Then I will explain it.
がっつり動いてがっつり食べる Let's
Man, I love doing this magic tricks, man. Anyway, we are back. And so what I just did, basically, I just rewrote the absolute value. Because think about it. When there's two, let's say in a more general term, let's say absolute value, there is, let's say, x minus y. And what does it really represent in here, x minus y in here? There's two ways we can rewrite it. First of all, is x minus y when x is bigger or equal to y. Or when y minus x, when y is bigger than x. Because both way, it will give us the absolute value. And basically, that's what I did. And right now, once again, I will do another magic trick to regroup this in a different way again.
再度挑戦すればいいからねそう再度挑戦すれば再度再度再度テスト
We're back from another magic trick. And here we are. So basically what I did in here, I changed it to xi plus yi. What is xi plus y exactly? It's just the points, but I just add the two coordinates together. And same here as well. And what about xi minus yi? What did I do in here? Once again, it's the two coordinate from the same point, but this time instead of doing an addition, I do a subtraction between them. So why don't I rewrite them again, and such that I will rewrite them as oopsie x plus y equal to addition, and x minus y will be subtraction. And here I just use sub because for simplicity wise. And right now I will regroup them, rewrite them again. So I'm gonna play another magic trick again.
このディオだ
And we're back. Basically what I rewrote in here, as you can see, x plus y, I changed it to addition, and x minus y, I changed it to subtraction. And as we can see in here, there's actually only two formula that will tell us the Manhattan distance. What is the first formula? Addition minus addition. What is the second formula? Subtraction minus subtraction. This is the two formula that we get. And right now I want you to think about it. How can we find the maximum Manhattan distance? And you know what? Let me ask you a more simpler question. Let's say we are in a 2D plane. And since the constraints say that all the point is positive in here, but it doesn't really make a difference. Let's just say, there's 2 points in here. You know what? Let me draw a few couple points in here. Where can we see, the greatest Manhattan distance in here? It's pretty obvious, right? It's this outlier here and this outlier in here. Why? Because if we do, let's say in here, the addition one of the addition in here, the positive one in here is the greatest. Oops, sorry, I spelled greatest wrong. And the other addition in here, what it is the smallest. So what does it really mean in here? It means we want to find the greatest addition
and the smallest addition. And of course, we also want to find the greatest subtraction and the smallest subtraction. And let's say we find, for this greatest as well, and this is also the smallest. And let me just clean it up a little bit, And if we find the greatest for this two and the smallest for this two, all we need to do compare 1 and 2, and we return the smaller one, which is also the third biggest maximum Manhattan distance. And that's it. Literally, that's it. And right now, let's go to try to implement this in Python. Sorry for writing. Yep. Let's go to Python right now.
All right now we are back at our last step, which is try to implement the code. So right now let's, rewind what we say. Right now we know how to find the maximum Manhattan distance, right? And we want to find the third largest one. And in order to find the third largest one, we need to repeat our process 3 times. Since we have to repeat our process 3 times, so why not we just, make a helper function. Make a helper function to help us not to repeat our code 3 times. And what do I helper function want to do in here? Purpose helper function. The first thing what we want to do is to find the maximum Manhattan distance. And what is the second purposes we want to do? Because once again, we want to remove the 2 points of the maximum Manhattan distance, right? So we want the coordinates. So it's like we want the pair of points. All right, so that's our helper function. So right now, let's try to think about it. What else do we need for a helper function in here? Because normally before we code, we want to make sure we have a good blueprint, just like engineering as well. When you make a car, you don't want to just go there and run around and figure out what's going on. You want to have a blueprint. You want to know what steps are you taking. You want to have an organized structure. And so let's think about it. Right now we know what we want, but how do we keep track of them? And we want to have the subtraction maximum, subtraction minimum, the addition maximum, and addition minimum. So there's 4 components we need to keep track of. Variables to keep track of. 1, addition max. 2, addition minimum. Third, subtraction maximum. And what about the fourth? The fourth is subtraction minimum. And yeah, that's about it. We just need to, iterate the for loop. And yeah, so right now we got a clear idea, and right now let's implement it. So right now, of course, let's say define helper function. And what do we want to tell the helper function as well? Oh, this is one of the things that I forget to tell you guys, which is when we want to, let's say when we reuse our helper function again, we want to remove exactly 1 point, right? Which is exclude 1 point to skip 1 point. And also, let me just put also have the ability to skip point if being told. So we will give a extra variable which is point, or we're gonna say by index, because we want to skip a specific index, right? So right now let's create the additional maximum. And how do we make sure we can update it properly, which is set at infinity. And of course addition minimum as well, because I, oops, my bad. I mean by this subtraction maximum because we want to make sure we are able to update it whenever we want. So that's why we want to set it to the greatest value. And not greatest, like the smallest value, because we want to keep track of the greatest. So we need to have to ensure that they are the smallest value. So flow infinity, this is one of the Python syntax. In case you don't know as well, it's good for initiate variable and to make sure you can update it later. And also it makes sure this number is going to be smaller than all the numbers that you're going to be reading through so we can update properly. And of course, that being said, Python also support the positive infinity. So right now at addition minimum and subtraction minimum is equal to flow infinity. And all right now let's iterate through the array. And also, just like you guys know, in Python there is something called enumerate. And what's good about enumerate is not only the fact that we are able to get the index of the array, but we are also able to get the element of the associated index as well. And it just make your code more neater, more cleaner, just why not? Just make your code cleaner. It's more elegant. And we have to make sure one thing as well, which is we skip the index, right? So if I equal index, are gonna skip it. Just continue, and that's it. And once again, I want to make things easier for readability, so I'm gonna just say xy point, because in here we can see like xy is within an array, so there is like some Python stuff in there. Basically, we can just break it down the array and just take the element out from it. And let's say if the array have three elements and we only want to get the first two elements, we can simply do this as well, because this means we only get the first two element of the array, right? So this works as well. In case you guys don't know some of the Python syntax, and of course addition is x plus y, right? And what is subtraction? Subtraction is x minus y, right? And we want to update that, right? So what we want to do is if addition is greater than the current maximum, we want to be able to update it. So we would say, we're gonna update it to the current addition. And not only that, we want the index, right? So we just say, hey, index I is equal to, the index right now. And you might ask why I don't initialize at the beginning, because if there is no, if- theoretically, if there is no a additional maximum is greater than the current, addition, then I don't even need to bother to look at it or to initiate it, because if such thing theoretically exists, that's mean it doesn't even exist in the first place. So that's mean there's nothing for me to even look at it. So I don't need to, initiate in the first place. And once again, just to make our code cleaner, neither. And of course, right now we want to look at the addition minimum, and the addition minimum, of course, is the opposite. If something that is smaller than the current one, we update it. Copy and paste, and here the index, update the index as well. And right now, let's update the subtraction as well. So if subtraction is bigger than the subtraction maximum, we update subtraction maximum to the current subtraction value. And of course, we update the subtraction maximum index as well. And of course, right now, what else do we got left to update, which is the subtraction minimum. And right now, voila, and that's it. And right now, what we need to do is just to find the greatest maximum Manhattan distance. And how do we do that? Like I mentioned earlier, we just basically find the greatest additional maximum, which we already do in here, subtract the smallest addition minimum, right? And who else do we need to compare? Which is the subtraction maximum minus the subtraction minimum. Oopsie daisy. Oh, Whew, what? Hey, and and it doesn't really matters in here if equivalent sign as well. I remember I did put equivalent sign in here, but if they equal, it doesn't really matter which one you return, right? So it doesn't really matter in here, and we just return. Let's say I want my first element to be the distance. So I'm gonna, I'm gonna put this as the distance. Then what else do we need to return? Which is the index for both of them. So sorry, I'm a little bit lazy, so I just, this is easier for me to type. And if this is not true, that's mean we return the subtraction, right? Because if it's not the addition maximum minus addition minimum is the greatest, that's mean it's going to be the subtraction maximum minus the subtraction minimum. Because there's only two possibility in here. Once again, yep, and we have to return the index as well. All right, everything looks good to me. All right, so right now we just need to call the helper function free time and that's it. So let's say, like I mentioned earlier, we're gonna use P1, P2 as a point just to keep track of them, and we're gonna call the helper function. And since there is no index, we're skipping to it. So let's just say -1 because -1 doesn't exist in the index. And right now, oh, and of course we need to make sure we only return the first element of the. Let me make this a array as well, which is easier for me to break it down like I show you in here, like how I break it down point in here. And actually, it's not 02, silly me. It should be 1 and the end, which is what we would do. We got the first element and then the second element. And then since we know the point, what else do we need to do? And I can make the code even neater, which is by return the minimum of helper function of P1. And what do we want to return? We want to return the first index, right? Because the first index is the distance. And of course, helper. And what is the second point that we need to check, which is P2. And of course, once again, it's 0 index, and that's it. And let's run the code. Yep, it's good. Let's submit it. Voila, that's it. If you guys like how I teach, or you guys want me to cover, something else, feel free to like and comment down below the comment section. Tell me, what else do you guys want to learn, and I can also, maybe covering like like dynamic programming, like a concept in general as well, and maybe some statistic concept, maybe like Monte Carlo Markov chain as well. Um, and also, this is my first time, doing my first YouTube video. If you guys don't think I do anything great or something that I can work on and improve on, feel free to comment down below so I know what do I need to work on as well. And also, right now I'm trying to look for a software engineering job. So if you guys know anyone that is looking for a hard software engineer and people that is good at solving problems, and I think I got a pretty good track record when it comes to trying to solve problems as well. Feel free to comment down in the comment section below so I can reach out to you guys and we can talk about the opportunities as well. And yeah, and thank you guys for watching. And I hope you guys have a nice day. And I hope you guys learn something new today as well. And peace out.